Now that we know what exactly is a linked list, let's just try to understand what are the different types of the linked list that we have, and let's try to understand what exactly are the common terminologies that we use whenever we implement some linked list in the future. So based on the way the values that we have inside the linked list are connecting to the next and previous values, we basically have three types of linked list. One is singly linked list, and the other is doubly linked list, and the third one is circular linked list. When it comes to singly linked list, right, here as you see on the screen we have a singly linked list. If you observe here, each and every value that we have in it, like I mentioned previously, will be created at the random memory location and should basically have the connections with the next values we have. In the case of singly linked list, right, the value whatever we have, each and every value will be only connected to the next node that we have in it. Remember that each and every value is connected to the next node only. That's the reason why, as we are having only one connection, only one link with the next value, we will simply call it as a singly linked list. Remember that, that is the reason. And the second linked list is nothing but doubly linked list. Now in the case of doubly linked list also, each and every node is connected to the next node like we have inside the singly linked list. Along with that, each and every node that we have will also have the connection with the previous node that we have inside that specific doubly linked list. For example, if you take the value false that we have here, right, it is connected to the next value, that is 1.23, and it is also connected to the previous value a. Remember that in the case of doubly linked list, we will have the connection with the next value and we will also have the connection with the previous value. That is the reason why, as we are having two links, we call this as doubly linked list. And the third type of linked list is nothing but circular linked list. The only difference that we have when we compare a circular linked list with a traditional linked list is that whatever the last value we have in that specific linked list, right, it will again have the connection with the very first value we have inside that specific linked list. Remember that as we are establishing a connection from last value to very first value, we are basically creating a circular linked list. That's why we call this linked list as circular linked list. Whereas in the case of singly linked list and doubly linked list, basically once we reach the last value, there is no connection. That basically means that there are no values. That's the reason why we are not having the connection. But when it comes to circular linked list, the last value we have, we basically have a connection from last value to the very first value we have inside that specific linked list. Based on, if you see here, right, this is a circular linked list which basically is having only one connection with the next value. That's the reason why you can also call this linked list as circular singly linked list as well. If at all, if you want to implement this circular linked list with doubly linked list, that means each and every value will have connection with the next and also has the connection with the previous value, then this circular linked list will basically be called as circular doubly linked list. Okay, so that is something that you need to remember. Based on the linked list that we are using for implementing that circular linked list, it can be circular singly linked list and circular doubly linked list as well. Okay, so those are the different types of linked lists that are possible. Now let's try to understand some of the common terminologies that we will use whenever we talk about any type of the linked list that we will implement in the future. When it comes to linked list, right, there are only two terminologies that you need to remember. One is head and the other is tail. And sometimes here we will basically use a term called node. Node is nothing but each and every value that we are creating at random memory location, right? That is nothing but a node. Here in the case of singly linked list, one is one node, false is one node, hello is one node. In the case of doubly linked list, hello is one node, a is also called as node. Remember that a node is nothing but a value we have inside that specific linked list. Okay. Now let's try to understand what exactly is a head and tail. Head is nothing but the very first value we have inside that specific linked list. If you take this singly linked list, right, the head node is nothing but, as the definition suggests, it is the very first node, which is nothing but A. In the case of doubly linked list, this one is nothing but a head node. Similarly, in the circular linked list that we have, one is a head node of that specific circular linked list. And the second terminology is tail node. Tail is nothing but very last value we have in that specific linked list. For example, in the singly linked list, hello is the tail node. In the doubly linked list, again hello is the tail node. And in the circular linked list, hello is the tail node, as you can see on the screen. Remember that only two terminologies, one is head and tail. Remember, these are very important as we implement singly linked list and doubly linked list in the future. These are something that we will be using very often. That's the reason why pay more attention, and remember that head is nothing but the very first node and the tail is nothing but very last node we have in the linked list. Okay, so those are the terminologies that we use for talking about any of the linked list that we will implement. Okay, those are the different types of linked lists that are possible, and those are the terminologies that we use whenever we speak about the linked list data structure. Now that we are aware of what are the common terminologies and what are the different types of linked lists that are possible based on the way we are having the connections with the values we have inside that specific linked list, let's just try to understand what are the common functionalities that we will be implementing as part of this specific course on any of the linked lists that we will be implementing. So these are the common functionalities that we will be implementing, and the very first function is nothing but push function. What exactly this push function does is it basically adds a new value at the tail end of the linked list. Obviously tail is nothing but the very last node, right? And after that we will basically introduce a new value into the linked list. And the next operation is nothing but pop operation, and this pop operation basically deletes the value we have at the tail end of the linked list that we are implementing. So tail is nothing but very last node, right? We will simply delete that last node from our linked list implementation. That is what this pop operation does. And the third functionality that we will be implementing is unshift operation. As part of this unshift operation, we will basically introduce a new value at the head of the linked list. Remember that push is basically used for adding the new value at the tail side of the linked list, whereas unshift operation is basically used for introducing a new value at the head side of the linked list. And whereas a shift operation is basically used for removing the very first value, that is whatever the head node that we have, we will try to remove it as part of the shift operation. And the next operation that we will implement is get. It will basically take the index from the user and it will go to that specific index and it will simply try to fetch that value that we have at that particular index given by the user. And the next operation is set. Set operation is basically used for updating the value we have at a particular position on a linked list data structure. And the next operation that we will implement is insert. Obviously, as we have already discussed about the adding new values at the head side and tail side, user may want to add the value at a specific position as the user desires. We need to support that functionality as part of this insert function implementation. Obviously, as part of the remove, we will basically try to remove the value that we have at a particular position that is given by the user, maintaining the consistency across all the values we have inside the linked list. And the next functionality that we will implement is contains functionality. What exactly this contains functionality does is it will basically take a value from the user and it will basically check if that specific value is available in the linked list or not. If it is available, we will return true. If it is not available, we will simply return false. Basically, contains functionality basically checks if a particular value is available in my linked list storage or not. Okay, so these are the common functionalities that we will be discussing. Besides this, we will also add one function called traverse. This traverse function is basically used for printing each and every value we have inside the linked list, right from head node to till the tail node, whatever we have inside that specific linked list. Remember that these are the functionalities that I will be implementing as part of the linked list that I will explain in the future videos. But remember that according to your requirement, you can add as many functionalities that you want. You can modify whatever the functionalities that we are implementing as well. But in my linked list, these are some of the functions that I will be implementing, covering all the cases, making sure that I am not introducing any abnormalities inside the linked list that I am implementing. Okay, so those are the common functionalities. In the next video, we will jump on to implementing the singly linked list and doubly linked list. Out of all those linked lists, we will basically implement these are the functions that we will be implementing. Okay, so those are the common functionalities that we will be implementing, irrespective of whether it is singly linked list or doubly linked list or circular linked list. These are the common functions that I will always have inside my linked list implementation. What all are the different ways we can implement the linked list data structure, be it singly linked list, be it doubly linked list, be it circular linked list, whatever we have according to the abstraction rules that we have set up. What all are the different ways we can implement any type of the linked list following the rules that we have specified. So we can also use arrays for implementing the linked list data structure, but that is not the most efficient way, because whenever we talk about the arrays, right, the entire memory that we need for storage will be a continuous memory block. That's the reason why even though we can implement the linked list data structure with the help of the array, that is not the best possible implementation, as it needs continuous block of memory. Okay, that is not the best case. That's the reason why what we will do is we will basically write our own custom implementation. That means that whatever the implementation that we do, right, we will basically define the nodes structure, and we will try to establish the connection between these nodes as well, based on the linked list that we are implementing. If it is singly linked list, each and every value will be connected to the next node only. If it is doubly linked list, each and every node is not only connected to the next node, but it is also connected to the previous node. If it is a circular linked list, the last value will be connected to the very first value. If it is a circular doubly linked list, the connection will be mutual, what you see on the screen. But anyway, those are the two ways we can implement the linked list data structure. Remember that we can implement the linked list using arrays as well, but that is not the most efficient way, because whenever we speak about the arrays, they basically need the continuous memory block. Okay, now that we have understood this, let's just dive into the implementation of singly linked list based on the abstraction that we have and based on whatever the terminologies that we already understood. And let's just try to implement all the common functionalities that we have understood any type of the linked list should always contain.